Yes, good morning, students.
Good morning, sir.
Yeah, my voice is audible.
Sir, audible, sir.
Okay, I will share my screen. Now PPT is visible. Yes, give me response. PPT is visible.
Yes, sir. Visible, sir.
Yeah, what is the slide title?
Visible, sir.
What is the name of the slide?
Porter Governor.
Yeah, Porter Governor. Thank you, ma. Yeah, last class we discussed about a Porter Governor. Whenever the device is there, how do you remember it? First, you go for introduction. Second, construction. Third one, working principle. Then fourth one, limitations. Yes, please mute yourself. Okay, first introduction. How do you introduce this Porter Governor? It is a gravity controlled type. Gravity controlled type. Under that, centrifugal type, energy controlled type governor. Right? Gravity controlled, centrifugal type, energy controlled governor. This is the introduction about Porter Governor. Now it consists of, then you go for construction. What it consists? It consists of four binary links. Okay, it consists of four binary links and two governor balls, one sleeve, and one governor shaft axis. The two binary links is connected to the governor shafts at the point O, that is called pivot point. Those two arms are called links are called as upper arms, and other end of the upper arms is connected to a governor balls. Then another two arms, that is called lower arms, are connected. One end of the lower arms is connected to governor ball, another end is connected to a sleeve. A sleeve is nothing but it is a vertical movement or linear movement of the component, and it is attached to the, it is hollow portion actually. It is where it is mounted here, it is mounted on the governor shaft axis, not directly connected to the governor shaft axis. It is slightly just over mount. This is a shaft axis, it mount over this. That's called as a sleeve. Okay, is a heavy mass. We can increase this mass of the component. That is a sleeve. That is the introduction, the construction, then working principle. Now initially the governor ball is the mass m, the radius of rotation is r. Okay, then the weight of the governor ball is acts vertically downward, mg. The weight of the sleeve also act vertically downward at the cg of the sleeve, vertically downward, that is capital mg. When governor shaft rotates at angular velocity omega, as the speed increases, what happens? As the speed increases, a radial a yeah, a force which acts radially outward in the governor balls. As the speed increases, a radial force acts outward, that is called centrifugal force. Due to this centrifugal force acts on the governor ball, the upper arms moves radially outward. Once the upper arms moves or the governor ball moves radially outward, the movement of the sleeve is connected to a throttle wall of an engine. Now once the sleeve moves upward, now when the governor ball moves radially outward, the lower arms also moves in this direction, right? Now the sleeve moves upward. Once sleeve moves upward, that mechanism is connected between the sleeve movement and the throttle valve opening and closing. Now when sleeve moves upward, throttle valve slightly closes, the amount of fuel supply is less. Now the engine power produced by the engine is less, the speed also less. Now that speed is transferred to the governor shaft axis. Now governor shaft rotates at a very low speed. After that, then due to the weight of the governor ball and the sleeve, the governor ball moves radially inward. Now the sleeve moves downward. Then once the sleeve moves downward, that is connected to the throttle valve through a mechanism. Now the throttle valve opens and amount of fuel supplies more. Then due to this increasing and decreasing the speed, that maintain the engine speed within the limit. That is the function of the Porter Governor. How it is controlled here? It is controlled due to
Your voice is
Sir,
breaking, sir.
voice breaking.
okay. Now, am I audible? Okay, your internet connection is unstable. Okay, now my voice is audible. Please check.
Yes, sir. Audible, sir.
Okay. Now, so due to when the speed increases in the governor shaft, the governor ball moves radially outward. Now that will closes the throttle valve. Then once the throttle valve closes, the amount of fuel supply is less. Then due to the weight of this governor ball and weight of this sleeve, weight of the sleeve, that moves, the sleeve moves downward, or the governor ball moves downward due to weight of the governor ball and weight of the sleeve. Means that is a what type of weight here? Gravity control. This is a weight is acts vertically downward due to gravitational force is acts here. That's why it is a gravity controlled type governor. Then our aim is to determine height and speed of the governor. Now we'll consider only the up portion. We consider only left side portion here. Left side portion of the governor that we draw here. Now upper arm, the angle separated upper arm or upper link with respect to the governor shaft axis, that angle is called as alpha. At the same time, the lower arm with respect to the governor axis, that is angle is beta. Now the tension T1 is occurred in the upper arm, T2 occurred in the lower arm. The governor balls is located at the intersection of the upper arm and lower arm. That point is A. What are the forces acting on the governor ball? One is a centrifugal force, it is mr omega square. Another one is a gravitational force due to that mass of the governor ball, that is mg. And at point B, the weight of the sleeve, it is m into g, that has split into
Onde não Junto, ganchila. Até Chachapal, Adil Shishu, Junto, ganchila.
is due to the weight of the sleeve. Total weight of the sleeve is mg, that acts on both the side at the point B and C. That's why divided by 2. That is weight of the sleeve is mg by 2. That also acts vertically downward. Now r is the radius of rotation of the governor ball. As you know, this angle is alpha. This also, if you draw a vertical line from point A, this angle is also a alpha. Due to what type of angle it is? Alternative angle, right? And this is beta, means this is also a beta. Again, this is also alternate angle. This is for what it is? Z shape it is. Now after that, we discussed about, so these are the representation, the notations what we used, and what are the forces acting on the governor balls. You can see that when both the governor sleeve, governor ball and the arms are in equilibrium condition, these are the forces are acting. There's a T1 tension in the upper arm, T2 tension in the lower arm, centrifugal force due to the rotating of the governor ball, mr omega square, and the weight of the ball is mg. Now our aim is to determine the speed and height of the porter governor. How to determine? There are several methods are there, out of which we'll go for use two methods. One is instant method of resolution of forces, means resolving the force into two components. One is horizontal, another one is vertical. Here the sleeve moves vertical direction, then we take vector sum of all the force acting on the vertical direction is 0, then resolve it, then you go for simplify, then you will get that speed and height of the governor. Another one is instantaneous center method. Instantaneous means at particular instant, where will be the position of the link. Based on the position of the link, we'll go for draw the what is the center location, center of the link movement. That is called an instantaneous center method. Now here for your syllabus, you have only a instantaneous center method. Now this is a method of resolution of forces. Now we resolve that force into two components. One is the vertical, another one is horizontal. Then you go for resolving all the forces vertically. That is upward force equal to downward force, or vector sum of all the forces acting in upward direction is equal to 0. Then you go for substitute that value, then simplify it. For this method is not for your syllabus. Now second one is instantaneous center method. As you know that when the sleeve moves upward, see that at point B, when sleeve moves upward and downward direction, at the same time, the upper arm is oscillate, right? Not it complete rotation, it oscillate here. Now it is similar to see that BAO. It's a what type of mechanism it is? It is a slider crank mechanism. It is similar to a slider crank mechanism, but slider crank mechanism, that mechanism located in what position here? Vertical position. This angular movement of upper arm that makes a sliding motion of the sleeve, right? Now here we go for draw the instantaneous center. We determine the speed and height of the governor by using instantaneous center method. Now, how do you determine the instantaneous center here? By considering link AB. Now, extend this OA, upper arm link, extend this OA and draw a line. And from point B, the slider moves vertically upward, right? Now, draw a line which is perpendicular to the movement here. That is perpendicular movement, the intersection of the OA extension line from point B, horizontal line. That intersection point will called as a I. That I is called as the instantaneous center for the link AB, right? After that, now we'll draw from point A, draw a vertical line. From the vertical line, what are the distance between that intersection of vertical line from the point A and the BI, horizontal line? That intersection point will called as a D, right? Now the distance between D and I, that distance is called as a C, and distance between B and D, that is called as lowercase letter b. Now what is the vertical distance between the shaft axis, the governor shaft axis and the upper arm intersect, that point O and the radius of rotation of the governor ball? This vertical distance is called as the height of the governor in the upper portion. Similarly, go for lower portion also in lower arm, that is called as a A. Okay, the radius of rotation of the governor ball is R. Then remaining things are same. That is, what is the force acting on the governor ball is mr omega square. The weight of the governor ball is mg. Then the weight of the sleeve acting on only one side, left side here, mg by 2. And the angle subtended here, now transfer this angle to the corresponding angle with the help of alternative angle or corresponding angle. Now what is the angle subtended here? Okay, up to this last class we discussed, and also we started the derivation, right? Now how do you determine the height and speed of the governor? By go for instantaneous center method. Now we'll take the considering an arbitrary movement about point I, vector sum of all the movement about a point I equal to 0. Now what is sign convention? The clockwise movements are positive, counterclockwise movements are negative. Now first consider what are the forces are acting here at the governor ball. First force is centrifugal force, mr omega square. That is a force. What is the equation for movement? Movement is nothing but force into perpendicular distance, right? Perpendicular distance. That is a basic equation for movement. So here, what is the force acting at the governor ball is mr omega square. First one is centrifugal force. What will be the perpendicular distance? What is this distance is? Yes, give me response to anyone. What is this distance is? Perpendicular distance is A. Now mr omega square into A, that produces a movement in what direction about I? In what direction it is? About I it is counterclockwise direction. Now movement force is mr omega square into A, that gives a movement. What direction it acts here? Counterclockwise, that's why negative sign comes here. Next, after that at point A, one more force is there, mg, that acts vertically downward. Now what will be the perpendicular distance? This perpendicular distance is C. Now what is the moment? Force into perpendicular distance, mg into C, mg into C. Now what type of movement about I? What type of movement? The force produces what type of movement? It produces a clockwise movement about I. That's why you get a plus sign. Next, one more force is acting at the point B. That force is mg. Force into what is the perpendicular distance here? This is a perpendicular distance, that is B plus C. mg into B plus C. Again, that produces what type of movement? That produces what type of movement? It produces a clockwise movement about point I. That's why you'll get plus sign. Only the three forces. One is centrifugal force due to governor ball. Second one, weight of the governor ball. Third one, weight of the sleeve. Apart from this, any other forces are acting here? No other forces are acting. Then you go for vector sum of all the moment about I is equal to 0, then equal to 0. Right? Once equal to 0 here, now send this term, send this equation to the right side. Send this equation to the right side. Now we'll get what are the remaining terms? We'll get mg into c plus mg by 2 into b plus c, that is equal to mr omega square into a. After this, now send this a to the left side. Send this a to the left side. Now mg into c by a plus mg by 2 into, send this a to the inside the bracket, you will get b by a plus c by a, that is equal to mr omega square. Now from the triangle you can see that what is c by a, what is c by a, and what is b by a. See that c by a, where is here? Now this is c, now this is a. Again, now voice is audible, please check.
Yes, sir. Audible, sir.
Audible, okay. Now see the from this triangle IAD. Now this is a right angle triangle and angle is, it is what? How much it is? Alpha. Now the side which is opposite to this angle. Now this is what side it is? Opposite side, right? So I'll write in the short form, this is opposite side. The side which is adjacent to the angle, that is called as adjacent side. Now I need, what is C by A? C is what? Opposite side. Divided by A is nothing but what? AD, that is the adjacent side. Opposite by adjacent, what will get here? Tan alpha will get. Right? Similarly, go for one more, B by A. What is B by A? B, see that this is a B and this is A. Again, if you consider a right angle triangle, ADB, angle subtended here, it is B. Angle subtended, it is beta. Sorry, angle subtended is beta. The side which is opposite to the angle B, angle beta, it is this opposite side. Now this will be the opposite side and this will be the adjacent side. Now what is B? B is nothing but opposite side divided by A is nothing but adjacent side. Opposite by adjacent, again you will get a tan beta by considering the right angle triangle ADB. Right? Now substitute those values. What is C by A? C by A is tan alpha. B by A is nothing but tan beta. Once you substitute and then go for further simplification. Now if you substitute the C by A is equal to tan alpha and B by A is equal to tan beta, now this equation will get. After that, now see that. Now from this second term, take tan alpha is outside and from this also take tan alpha is outside. Okay, from the whole equation in the left side of the equation, first term, second term, take tan alpha outside. Once you take tan alpha outside, here, what you will get? In the first term, you will get mg plus, in the second term of the left side equation, mg by 2. If you take tan alpha outside, you will get tan beta divided by tan alpha plus 1. That is equal to mr omega square. Now what we will do, we will go for take tan beta by tan alpha for further simplification. Instead of substituting tan beta by tan alpha for each simplified equation, for that I will go for put some constant. That constant is called as a k. That is tan beta by tan alpha is equal to k. Then remaining one, tan alpha. What is tan alpha? Now see this right angle triangle OA called as, this is okay, I'll take this point is E. I think the screen is visible. Take this point is E. Now from the right angle triangle, OEA. What is tan alpha? Tan alpha is nothing but opposite by adjacent. This is opposite side. Now this is adjacent side. opposite by adjacent. That is R, opposite side is R, adjacent side is H. R by H. Now substitute tan alpha is equal to R by H and tan beta by tan alpha is equal to K. Then further simplify it. Now next slide is visible. Please give me response.
Yes, sir.
Yeah. Now substitute tan alpha is equal to R by H and tan beta by tan alpha is equal to K. Now substitute, then further simplify. Now finally we'll get this. Then our aim is to calculate what? H, height of the governor. That height of the governor is equal to mg plus mg by 2 into k plus 1 whole divided by m omega square. Now send this m omega square inside whole divided by m omega square. Now split into that. Now send this m omega square inside the bracket. Now you get mg by m omega square plus mg by 2 into k plus 1 divided by m omega square. Finally get cancelled. Finally, what equation you'll get here? H is equal to g divided by omega square plus mg by 2 into 1 plus k whole divided by m omega square. Now this is the height of the governor. This is the height of the governor, where h is the height of the governor. Now where we'll get the speed of the governor? The speed of the governor is nothing but omega, angular velocity. As you know that angular velocity omega is nothing but what? What is general equation for angular velocity? 2 pi n by 60 radian per second. You substitute omega is equal to 2 pi n by 60. Then again simplify it. Finally, you'll get n equation. That is the speed of the governor. So read the question. Whether they may ask for derivation for height of the governor or speed of the governor. If they ask for height of the governor, only up to this you derive it. That's enough. If they ask for speed of the governor, now we go for substitute, take omega square common, then take omega is equal to 2 pi n by 60. Then you express that what is the value of n in terms of equation. Clear? Now for this, you should remember this equation. Height of the governor is equal to g by omega square plus mg into 1 plus k whole divided by 2 times of m omega square. Now this is the equation. This is the height of the governor. Here is not visible here. What we are considering is we are neglecting the friction. We are neglecting the frictional force. Now where is the frictional force? Now where you get the frictional force? Now frictional force exists when sleeve moves upward. Okay, a force which resists between the governor shaft axis and the sleeve. That force is acts here that resists the movement of the sleeve. That is called as a frictional force F. We are neglecting this here for our derivation. We are neglecting frictional force is 0. There is no friction at all for theoretically. But when we go for next derivation, we will consider the frictional force. Yes. Any doubt regarding this derivation? Usually they ask the derivation for either Porter governor or Hartnell governor. If they ask for derivation for Porter governor, problem is on Hartnell governor. Our derivation is on a Hartnell governor, we may expect the problems on Porter governor. Okay. Here we go for determine height of the governor. How to determine? By instantaneous center method. First you determine what is the instantaneous center for the link AB. Then we will go for take a moment about point I is equal to 0, means the vector sum of all the moment about an arbitrary point I is equal to 0. Take clockwise movement is positive, counterclockwise movements are negative. Then you go for simplify it. Then finally we'll get this equation. That is height of the governor is equal to g divided by omega square plus mg into 1 plus k divided by 2m omega square, where g is nothing but acceleration due to gravity 9.81 meter per second square. Omega is nothing but 2 pi n by 60. Capital M stands for mass of the sleeve. G again 9.81. K is nothing but tan beta by tan alpha. Small m stands for mass of the governor ball. Capital M is mass of the sleeve. Small m is mass of the governor ball. Clear? Is any doubt regarding this? Any doubt regarding the derivation? If you have doubt, please unmute yourself and ask the question.
Sir, how many marks they will give, sir? The
For
derivation.
6 to 8 marks for derivation.
Yes.
Okay. Shall I move on to the next topic?
Yes, sir.
Yeah, now up here we'll determine the height of the governor by neglecting the frictional force. Frictional force exists between the movement of the sleeve and the governor shaft axis. Now next what we'll do, now we'll consider the friction. If you consider friction, see that. If you consider friction, where the friction exists here, now when the governor ball moves radially outward, when governor ball moves radially outward, the sleeve moves in what direction? Upward direction. Once sleeve moves upward direction, what is the frictional force? The frictional force moves in downward direction, that is F. Right? Now that frictional force added to where? Added to this mg. Yes or no? The frictional force is added to mg. Mg is acting also downward. Frictional force acting also in downward. Now what is the total force here? Mg plus F. Now when you consider plus F, when sleeve moves upward, when sleeve moves upward, frictional force is downward. Suppose, for example, if the frictional force is if the sleeve moves in downward direction, if the sleeve moves in downward direction, now tell me what is the frictional force, in what direction it is? Yes, anyone unmute yourself, tell me if the session is ended. Now again rejoin that session, okay? Yes, anyone unmute yourself, tell me that when the sleeve moves downward, what is the frictional force is? Frictional force is opposite to the motion of a body. The force which is generated when in contact to each other, if the body moves in this direction, means frictional force is opposite to that one. Means frictional force act here upward. That frictional force act upward. Now what is the total force acting here? By considering in the sleeve it is mg. Now up force, frictional force acting upward direction means minus times of F. Right? Yeah, that is a statement here. See that the force, effect of frictional force on the speed and height of the governor, that is a heading. The force of friction always acts in a direction opposite to that of motion. When the sleeve moves up, the force of friction acts in the downward direction, right? When the sleeve moves upward direction, the frictional force is what? Acts in downward, right? The force of friction acts in the downward direction. When the sleeve moves up, the force of friction acts in the downward direction. And if the sleeve moves downward, and the downward force acting on the sleeve, so what is the total force acting on the sleeve? It is mg plus 2. See that F is acting downward, mg is also acting downward. What is the total force acting on the sleeve? It is, sorry, capital M G plus F small f. That is the total force acting on the sleeve vertically downward, because when sleeve moves upward, frictional force is acting here opposite to the motion, that is downward direction. Now similarly, see that similarly, when the sleeve moves down, the force on the sleeve will be minus F. See that when the sleeve moves downward, what is the frictional force act here? The frictional force act here upward direction, always opposite to the motion of a body. Now mg is acting here in what direction here? Downward direction. That mg is acts downward direction. Now what is the total force acting that produced by the sleeve? It is mg is acting downward, F is acting upward, right? Minus F. Now this is the total force acting on the produced by the sleeve. See that in general, the net force acting on the sleeve is, in general, the net force acting on the sleeve, it is mg plus or minus f. Why do you call it as plus or minus? The sleeve movement up and downward direction. The frictional force also opposite to the movement of the sleeve. Now depending upon whether the sleeve moves upward or downward, then wherever mg is there, there you can take plus or minus f. See that? Now this is the equation, remember, when considering a frictional force between the sleeve movement and the governor shaft axis. The h is equal to height of the governor is equal to g by omega square plus mg, capital mg, plus or minus f into 1 plus k whole divided by 2 times of m omega square. Now this is the height of the governor by considering what? Frictional force. Now that what is the difference here? Only that consider plus or minus f in that capital mg. That is the difference between by neglecting the friction in the frictional force and by considering frictional force between the sleeve and governor shaft axis. Yes, any doubt regarding this? If you have doubt, please unmute yourself and ask me the question. No doubt? Shall I move on to the next slide? Please give me response.
Okay, sir.
Okay, now after that, our aim is to determine what will be the effort of the governor. Now, what will be the effort of governor? See that our aim is to effort of governor. Effort means how much force is required to move the sleeve upward direction, or how much force is required to move the sleeve downward direction. That is called as a effort. The force required to rise and fall of the the movement of the sleeve. That force required called as a effort of governor. Now again you consider by neglecting the friction here. We know that height of the governor is h is equal to g by omega square plus mg into 1 plus k whole divided by 2 times of m omega square. Now take LCM 2m omega square into 2m omega square. Take LCM from these two equations, from the first and second term of the right hand side of the equation. Take LCM. LCM is 2m omega square. Now numerator becomes here omega square get cancelled. 2m into g will get numerator. Then 2m omega square same it is. You will get mg into 1 plus k you will get, right? Now called as this is equation number 1. Once you call equation number 1, now when you get the sleeve movement upward, when initially the angular velocity is omega, now increase that angular velocity from c.
Sir, voice is breaking, sir.
Okay. 1 minute. Yeah, now voice is audible. Am I audible? Yes, please give me response. Yes, please give me response. My voice is audible?
Yes, sir. Audible, sir.
Okay, ma. Okay, whenever the is not audible, please inform me. Okay. Now consider initial equilibrium speed is equilibrium speed of the governor is omega. Now when we will get the sleeve movement upward and downward, whenever the speed increases or decreases, then only the sleeve moves downward and upward direction, right? If its speed increases, the sleeve moves upward. If its speed decreases, the sleeve moves downward. Now let omega be increased to c times of omega. If omega is the angular velocity of the governor shaft increases to c times of omega, then what will be that? Some amount of force will resist to movement of the sleeve. That is, E be the force applied on the sleeve to prevent its moving. Means how much effort is required here? E is the effort is required to resist that movement of the sleeve upward. Thus the force on the sleeve is increases to how much? Mg plus E. How much amount of force is required to move the sleeve? That is initially is mg plus Fe is the effort is required to move the sleeve. When the governor shaft increases speed from omega to c times of omega. Now from the equation 1, wherever omega is there, substitute omega instead of omega, c times of omega. Wherever mg is there, substitute mg plus e. Now we'll get the equation number 2. See that, compare equation 1 and 2, you see that 2 mg small mg plus wherever capital mg is there plus e will get. Wherever omega is there, now you can see the c omega. Right? Now after this, now we'll go for divide equation 2 by 1. Our aim is to determine, what is our aim? Our aim is to determine how much effort is required to move the sleeve. This is the aim. This is the question mark. E is the unknown. Now what we will do, we will go for divide the equation 2 by 1. Divide equation 2 by 1. So left hand side is hh, that will get cancelled. Right hand side, see that 2 times of mg plus capital mg plus e times of 1 plus k whole divided by 2 times of m c omega whole square whole divided by equation number 1. 2 times of mg plus capital mg into 1 plus k whole divided by 2 times of m omega square. Now 2 get cancelled. M get cancelled. Now after that, what is the next? Now see that. Now what you will get? Now take 1 by c, the c omega whole square is there, it becomes c square omega square. Again omega square also get cancelled, right? Only 1 over by c square, take this outside. The rest of the thing is same. Numerator will not changes. Only denominator term will changes.